All right, we are going to go through lesson one of our functions course here. I talked a little bit about functions over the past few days and some of the aspects of this course that we're going to be focusing on, and how this course kind of builds off of our grade 11 functions course. So today, again, might be a little bit of a review of what we've done over the last few days with the prereq skills. But again, we're just going to kind of hone in on some of these key things that we're going to be focusing on in Unit 1 specifically. Okay. So Unit 1 does focus mainly on uh, functions in general. Now, just give me 1 second. Okay, so it does focus on characteristics of functions. That is what the title of our unit is called. So we're going to be looking at characteristics of functions. We'll be looking at a couple specific functions, for example, the exploring the absolute function. We'll take a look at sketching graphs. We'll take a look at what we call piecewise functions. And then I haven't added the lesson there yet, but we will also be looking at inverse functions. Okay. Uh, if you want to print out these notes, I am going to keep an incomplete version there for you. Once the note's completed, we'll see if or maybe I'll post another incomplete version for you to print out. But I am going to fill out this note for you now. Okay. If you didn't print it off already, what I'll try to do is I'll post one below. Okay, here we go. So, functions. What is a function? Okay. So the idea here is a function is a special relation. It's a relationship. A function is a set of ordered pairs. Now, when we say ordered pairs, maybe you're wondering what that means, but if not, that's fantastic that you know. Ordered pair is referring to coordinates. Okay, an ordered pair. These are in order, coordinates are in order. The x coordinate comes first, the y coordinate comes second, and it's a pair of numbers. That's how we get ordered pairs, for which, excuse me, every x, there is only one y. Okay, simply no repetition in x and y values. That's kind of what we mean there. Okay, and no times that, no repetition in x values. All right, so just only one y for every x value. Okay, so can we look at maybe some examples of what this looks like in particular? Well, I could draw, for example, and I'll kind of give you an example. So let's say I had a table of values and I had x, y, right? Now let's say in this table of values, I was giving you some coordinates. So let's say I was 2, 4, 5, 8. Another coordinate might be 3, 7. And then maybe I say 2, 6. Okay. This no longer becomes a function as soon as I repeat an x coordinate. Because I now have the x coordinate of 2 twice and for different y values, this is no longer a function. Okay? That's kind of the idea. A function can only have one y value for each x value. Okay, you have another kind of example here. This one is an example of a function. 2, 3, 4, 5, 6, 7, 8, 9. There's only one, the x values only appear one time each. Okay, you may have seen last year, your teacher may have drawn, so I'll give you an example of a function. Your teacher may have drawn, right, these little circles where you have maybe -2, -1, 0, 1, and 2. And maybe I have 5, 6, 7, 8, and well, that's funny. 5, 6, 7, 8, and 9. Right? So maybe here we have 2 goes to 5, 1 goes to 6, 0 goes to 7, 1 goes to 8, 2 goes to 9. This is a function. Okay? Each x value only has one y value. Now, we can try that again. 2 goes to 6, 1 goes to 9, 0 goes to 5, 1 goes to 7, 2 goes to 8. Again, this is still a function because each x value only goes to one y value. Let's do this again. 2 to 6, 1 to 6, 0 to 6, 1 to 6, 2 to 6. They all go to 6, But notice that each x value, what I should have here is a little circle here. These are my x's, these are my y's, only goes to one y value. Okay? So this is the key. As soon as one x value goes to two different y values, then we're in trouble. So we get into trouble when we do this. 2 goes to 5, and 2 also goes to 6. 1 goes to 7, 0 goes to 8. 1 goes to 8, and 2 goes to 9. Notice here, the problem lies right here, where we have the x value of -2 goes or has two different outputs, one of 5 and one of 6. That makes this no longer a function. Okay? So that's the key there. That's what we're looking for, is when each x value only goes to one y value. Okay? So I'll draw an example of a function. So here's an example of a function. Right, nothing goes to 9 maybe. Actually, maybe we'll add a 3 here. And maybe this one goes to. So just to keep in the notes, I'll keep that there. That's an example of a function. Non-function. So let's say I'll do an example of a non-function. So we have x coordinates, we have y coordinates. Let's go -1, 0, 1, 2, 4, 6. An example of a non-function would be if this 1 goes to both. So because of this part here, because the -1 has two y or two outputs, it is not a function. Okay? In grade 9, you would have also maybe looked at not grade 9. In grade 11, you may have also looked at the vertical line test. And so what the vertical line test is saying is if we have a graph, if we're looking at a graph, we can tell if something is a function or not based on the graph. And the way to do that is to look at if any line passes through more than one point, if any vertical line passes through more than one point on a graph, then it is not a function. Use when given a graph to define a function. So let's look at 3 examples. Okay? Let's look at a parabola. If I draw a vertical line here, or an infinite number of vertical lines, since these vertical lines never pass through more than one point, this is a function. Let's try another one. Let's try a trig. Let's try a sine or cosine graph that's been shifted slightly. Again, I'm going to draw vertical lines all the way through. Do any of these lines ever pass through 2 points on my blue graph? No, they do not. So this is a function. And lastly, let's try a circle. If I drew a circle, right, because you can write an equation for a circle. It's like x squared plus y squared equals 9, something like that. If I draw vertical lines for the circle, do we pass through 2 points? Yes, we do. We pass through 2 points here and here, here and here, here and here. And so therefore, not a function. Okay? Vertical line test works on graphs specifically. And the way that we kind of relate these two things is for this x coordinate here, there are two y values here and here. For this x coordinate here, there are two outputs or two y values. So that's kind of how it relates to the above. Okay? Now let's try these 2 examples. So function notation, and again, I talked a little bit about this, but function notation basically is saying that f of x, function notation, is used to represent values of the dependent variable. The y variable is our dependent variable, and so all we say is y is the same as f of x. So a y coordinate is equal to f of x. Okay, it's just a different way, a more fancy way of writing y. Okay. So example 1 says h of x is equal to this, 3x squared plus 2x minus 7. It wants us to determine a couple things. It wants us to determine h of -2. Well, we did this. Okay, we did this in our little review. So all I'm going to do is I'm going to sub -2 into my equation. And I'm going to simplify. So that becomes 3. Oh, love when I say one thing and write another. Minus, look at that, minus 4 minus 7. That's 12 minus 4 minus 7. That's equal to 8 minus 7, which is 1. Okay? Let's try the next one. So with the next one, notice how we're looking at what is h of 0 and h of 2 minus 1. Well, this right here is h of, what's 2 minus 1? H of 1. It's just trying to trick us, just trying to throw a curveball at you. Okay? So that's h of 1 and h of 0. Well, I need to determine what each of these things are. So let's first figure out what h of 0 is. So if I sub 0 into my equation, what do I get? I get 7. Or sorry, negative 7. If I sub 1 into my equation, what do I get? Three plus 2 is 5, minus 7 is negative 2. So these are my two values, h of 0 and h of 1. And the question wants to know, well, what is h of 0 minus h of 1? Well, h of 0 is negative 7, and h of 1, we're subtracting, is negative 2, and 7 minus negative 2 is negative 5. Okay? That's all we're doing there. You're subbing them in independently and then figuring out what your solution is. Okay? All right. Let's continue. This is a short note, again, pretty much review of what we've been doing. If f of x is 3x minus 1, so it's given us a function, it says find the value of x if f of x is negative 5. So it's telling us what f of x is. So we're going to sub this in for f of x over here. So it becomes negative 5 equals 3x minus 1. Well, we need to solve for x. So let's do a little rearranging. Negative 5 plus 1 equals 3x. That is negative 4 equals 3x. Divide by 3, divide by 3. That goes away. We're left with x equal to negative 4 over 3. And I think I've told you this already, but I'm quite happy with that left as a fraction. You could write negative 1.3333. You could write as negative 1 and 1/3, a mixed number. But 4 over 3, negative 4 over 3, an improper fraction is perfectly acceptable solution here. Okay? Example 3, and then that's it. So this is a short lesson, like I said. We're looking at just function notation and then specifically domain and range. Okay? Now, domain and range. Let's think about this from yesterday. We did a little bit of focusing on this yesterday. I talked about the parent functions, understanding what the parent functions look like, and then looking at our transformations and how that's going to impact our domain and range. So let's first look at this function here. The parent function here is y equals x squared, okay, which looks like this. Okay, our graph, I'm going to do a little zoom in here. The two things that are applied to our graph here, the two key things, well, actually, there's three keys. This +1 shifts our graph left. This -3 or -3 moves our graph down, and this -2 flips our graph. Okay, so basically what we have, so we're going left 1 over to the left 1, we're going down 3, 1, 2, 3, and our graph is being flipped. So our vertex here is -1, 3, or -3. That's our vertex. Now, can we write the domain and range of this function? Absolutely. Our domain is x is an element of all real numbers. Well, that's always the case for a parabola. And our range, well, we can do that as well. Y is an element of all real numbers such that y has to be less than or equal to -3. Okay, it's less than or equal to -3, which is this line right there. Okay. Next one. This is a circle. And you may have looked at circles a little bit last year. I think you could toss this into Desmos if you're not sure what circles look like. But basically, what this one looks like. Now, why does that always happen to me? I need one of those cool gloves that don't make my hand hit the other buttons. What this graph is this graph is a circle with a radius of 3. Okay, so which means this is positive 3, this is positive 3, this is negative 3, and this is negative 3. Okay? This domain and range, the reason why I put this one on here is for you to kind of be tested a little bit and to kind of see what function notation can look like and how we can write it. Okay? So notice here that my domain, okay, my domain, the x coordinates that this graph exists for are between negative 3 and positive 3. It doesn't go anywhere past or outside of that. It doesn't go any greater than 3, and it doesn't go any less than 3. So for this, what we're going to write is that our domain, again, is always an element of all real numbers, such that, so the way I like to write this is I always like to start with my number on the left, my low number. So negative 3 is less than or equal to x, which is less than or equal to 3. Okay, we write our symbols go the same way, pointed the same way, our left limit or our lower limit and our upper limit. Okay, our range is actually going to be basically the same thing because it doesn't go above. Our y coordinates do not go above 3, and our y coordinates do not go below 3. So it's going to be basically the exact same thing, except we are substituting x for y and d for r for range. Okay, that is our domain and range of that circle. Next question. This is a reciprocal function. Okay, from memory, what does a reciprocal function look like? It looks something like this. Okay, this one here, our domain. Well, what x values does our graph exist for? Our x can be any number except our x cannot be 0. The reason x can't be 0 here is because if you try in your calculator, you can try it right now, you can try it tonight, you can try it tomorrow, but if you try to divide 1 by 0, you're going to notice that you're going to get an error. Okay? That's impossible to do. You can't divide 1 by 0, so therefore x cannot equal 0. Our range, similar. Our range actually here, if you look at your graph, you can kind of see that it's getting closer and closer to the x-axis, but it's never actually going to touch our x-axis. So in this case, we're going to say that y can never equal 0. Okay? Your y coordinate can never be 0. Now maybe you're wondering, why can my y coordinate never be 0? Well, you can tell by looking at the graph, but let's try to sub 0 in to our equation for y. If I say 0 equals 1 over x, here's a problem for you. Can anybody figure out what number I divide 1 by to get 0? I'll move on while you're thinking about that. And hopefully you realize that it's actually impossible. There's no number you can divide 1 by to get 0. Okay? Next one. Okay, this graph here, we're looking at a square root function. Okay, a square root function from memory looks like this, right? Something like that. This square root function in particular, this is our d value. We know it's our d value because it's under the square root with the x. If it was our c value, it would look a little bit like this, right? That's the difference. C is always outside, D is always inside, okay? This graph has been, remember, it's counterintuitive, so it's -1. I always think, oh, that would be to the left. That is a spam call. I'm going to decline that. So this is opposite. Whoa, they're calling me again. That's weird. Oh, it's a WhatsApp call. I don't know what that is. Okay, I'm going to decline that again. X -1, this is going to be a shift to the right. So we're going to shift to the right 1 unit. My graph looks very similar. Everything's shifted to the right. I don't know why it disappeared. It's going to be like this, where this value is 1. So now we can write our domain and range of this graph. Our domain is going to be x is an element of all real numbers such that x is greater than or equal to 1. And our range, our range is going to be why do I say x? Y is an element of all real numbers such that y, and notice, look at our y's, it doesn't go anywhere down here. It's only greater than 0, so y is greater than or equal to 0. Okay? Let me erase that scribble. Okay. Last one. Oh, no, 2 more. Ooh, interesting. 2 more. Y squared equals x squared. Okay. Let's finish this up here. So we're going to go this one here. This graph here is an exponential graph. You would have looked at exponential graphs last year. An exponential graph looks something like this. Okay. What is our domain based on that graph? Well, our domain is x is an element of all real numbers. That graph goes forever to the left, forever to the right with no restrictions. And our range is, again, y is an element of all real numbers such that, notice y has to be above the y-axis, the x-axis. It never touches the x-axis because there's no value. I can never make, right, we could do the same thing. 0 equals 2 to the power of x. What exponent, what number could you put up there to make that 0? Well, you can't. 2 to the power of nothing is ever going to be 0. So we say here that y is greater than 0. Okay, not equal to because it's never equal to. And lastly, okay, this is an interesting one. This graph here, basically with functions, if we want to graph a function, we typically want to have y by itself. So what I'm going to do here is I'm going to take the square root of both sides. Okay, so the idea here is that y is equal to the plus or minus of x. Okay, plus or minus x. Now, what that means is this graph looks like, let's say, so let's say x was 2, right? Let's plug 2 in. So y equals plus or minus 2. So when x is 2, y is plus or minus 2. What does that look like? So I said when x is 2, y is either plus or minus 2. So when x is 1, y would be either plus or minus 1. When x is 3, y would be plus or minus 3. So this actually looks something like this. This is an obviously a kind of like an absolute function. I don't know why I keep pulling that thing up. Kind of like an absolute function on its side. That is an interesting function. Now that is actually not a function, does not pass the vertical line test, so not a function, but we can still write the domain and range of this graph even though it's not a function. Our domain here is going to be that x is an element of all real numbers such that x is greater than or equal to 0. And our range is going to be y is an element of all real numbers. Notice that y goes all the way up and all the way down. Okay? Hopefully that made some sense. I will answer any questions that you have tomorrow. If you have any questions about the homework, I'll take that up all tomorrow. I won't take it all up, but I'll take some of it up if you have questions. Otherwise, that's the note for today. That's a little intro to functions. What is a function? What do we know? Function notation. How do we use function notation? And a little bit about domain and range. So good luck with those questions. Have an excellent rest of your Thursday, and we will see you all tomorrow.